Welcome to lecture number 99 of digital electronics. In lecture number 97-98, we were dealing with the design of counters. We have dealt with mod 3 counter and mod 6 counter. Now, in this lecture, we are going to deal with, in the previous lectures we have already dealt with up counters. So in this lecture we will be dealing with an example of down counter. Then we will go with the design of up down counter. That means the counter which can count in the ascending order as well as descending order. So coming to the question. First question, I am going to design a down counter. That is an example here. So first question, design a 3-bit down counter. Design a 3-bit down counter. So that is the question. So here bit number is given. So one flip-flop can store 1 bit of data. Therefore, what is the first step? First step is number of flip-flops required. That is equal to 3. Now 3-bit means it can count from 000 to 111, but that again in a down counting fashion. That means it should count from 111 to 000. Of course, initially the state of the counter will be 000 and next state will be 7. We should count back. So step 2 is I am drawing the step 2 is I need to select which flip-flop. Selection of flip-flop and drawing its excitation table. So here I am going to use D flip-flop. Because nothing is specified, so I can go for D flip-flop or delay flip-flop. So how do you draw the excitation table of D flip-flop? So I am having a present state, that is Qn. Next state, that is Qn plus 1. So what is the value of D? So it is 0, 0, 0, 1, 1, 0 and 1, 1. So what is basically D? D is equal to Qn plus 1. So you can write the 0, 1, 0, 1. Now coming into the present state, now coming into the state diagram, step 3, that is a state diagram. I want to explain the state diagram. How to go with the state diagram? So initially it will be 0, 0, 0. Initially the value will be 0, 0, 0. I am going to design a down counter. Then it will come to 1, 1, 1. From that it will again down count. That is 6, 5, 4. That is 1, 0, 0, 4, 3, 2. That is 0, 1, 0, 1, 0, 0, 1 and back. So again this 0, 7, 6, 5, 4, 3, 2, 1 and 0. That means coming to 0, the next state will be 7. Now I am going to draw the present state next state table. Present state, that is a step. So that is come to step 3. Step 4. Step 4 is present state next state table along with the excitation table. So here I am having say 3 bits. So present state I am having it as Q3, Q2, Q1. Next state is Q3, Q2, Q1. Next state of Q1. Now I am having only 3 flip-flops. So I am having D3, D2 and D1. So which are the states? 0, 0, 0, 0, then 0, 0, what is the next state? 1, 1, 1. Now coming into 0, 1, that is 1, 2, 3, 4, 5, 6, and 7. Now if it is 1, what is the next state? If it is 1, next state is 0. It is 1, next state is 0. If it is 2, next state is 1, because it is down counter, right? Direct down counter. 2 means it is 1. Now 3 means it is 2, 0, 1, 0. 4 means it is 3, 0, 1, 1. Also 5 means it is 4. 1, 0, 0, that is 4. Yeah. Sorry, it is, this 3, 4, 5, so this is 1, 1, 0. Okay, 1, 1, 0, 1, 1, 0 is 6, 6 means it should go to 5. 5 is 1, 0, 1. Now, if it is 7, okay, if it is 7, what should happen? If it is 7, it should go to 6. That is 1, 1, 0. Now, how will you write for D3? D3 is equal to next state itself. That means you can write it as Q3 of next state. That is 1, 0, 0, 0. 0, 1, 1, 1. D2 means it is next state. That is 1, 0, 0, 1, 1, 0, 0, 1. D1 means 1, 0, 1, 0, 1, 0, 1, 0. Now I need to derive the expression for D3, D2 and D1 as a function of present state Q3, Q2, Q1. That is what is required. Now I am going to derive the expression of D3. So I am going to derive the expression of D3. So before that, let me put the decimal numbers. That is 0, 1, 2, 3, 4, 5, 6, and 7. So I am going to derive the expression for D3. So I am drawing a K-map here. Drawing a K-map 1, 2, 3. It is a 3 variable K-map. So here what I have is Q3, Q2. This is Q1. This is 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So this is 0, 1, 2, 3, 4, 5, 6, and 7. So what is D3? It is 0, 1, 2, 3. It is 0 is 1, 2, 3, 4. It is 1, 2, 3, 4. It is 0. 1, 2, 3, 4. It is 0. 5, 6, and this one. 5, 6, and 7. It is getting the value as 1. Now how to find the expression for D3? We can club these two. If I am clubbing these two, what is the expression? It is Q3, Q2. Right? This is Q3, Q2. Q3, Q2. Then, what else we can club? We can club these two. So what is common there? Q3 is common and Q1 is common. So it is Q3, Q1. Therefore, we can write the expression of D3 as Q3, Q2 or Q3, Q1. Okay. So that is D3. Now I am going to derive the expression for D2. So D2 means I will draw another K-map. Okay. So this is step 4, this is step 5. I am going to step 5. This derivation of expressions. Derivation of expressions. Okay. So again I am going to derive D2, right? So 1, 2, 3. So here I am having Q3, Q2. This is Q1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. 0, 1, 2, 3, 4, 5, 6, and 7. Now how to proceed further? Okay. So for 0 it is 1, 2, so it is 1, 192 it is 0, 192 it is 0, 3 and 4 it is 1, 3 and 4 is 1, 5 and 6 it is 0, 5 and 6 it is 0. For 7 it is 1. Now how will you club? You can club these two. If I am clubbing these two, what is it? Which is common? Q2 is common here. Here Q2 is common. Here what is common? Q1 is common. So that is Q2, Q1. Then you can club these two elements. You can club these two. If I am clubbing that two, what do I get? Which is common there? Q2 bar is common and Q1 bar. So this Q2 bar, Q1 bar. Therefore, what is D2? So you can write D2 as Q2 Q1 or Q2 bar Q1 bar. Okay. Q2 Q1 or Q2 bar Q1 bar. That is it. So that is D2. Next one I am going to derive D1. I am going to derive the source for D1. Drawing the K-map again. D1. So it is here it is Q3 Q2. This is Q1. 1, 2, 3. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. This is 0, 1, 2, 3, 4, 5, 6 and 7. Now coming into 0, 0 is 1, 1 is 0, 0, 1, then 2 is 1, 3 is 0, 2 is 1, 2 is 1, 3 is 0, 4 is 1, 5 is 0, 4 is 1, 5 is 0, 6 is 1, 7 is 0, 6 is 1, 7 is 0. So what is the equation? You can club these four. And clubbing a quad, what will you get? Which is common? Q1 bar is common. So that is Q1 bar. Therefore we can write D1 is equal to Q1 bar. Okay, so I am writing the instructions for D3. What is D3? D3 what I am having is Q3 Q2 or Q3 Q1. Q3 Q2 or Q3 Q1. Now what is D2? D2 is Q2 Q1, Q2 Q1 or Q2 bar Q1 bar. Now what is D1? D1 is Q1 bar. Now I am going to draw the logic circuit. So first of all I will draw D3. Okay. I am having only one input D3, Q3, Q3 bar. So here I am having a clock. Then next one is I am having D2, D2, Q2, Q2 bar. Last one is what I am having is D1, D1, Q1, Q1 bar. Now what is D3? D3 is Q3 Q2. Okay, so I will give a AND gate here. It is Q3 and Q2, then Q3 and Q1, 2 AND gate. Q3 and Q1, you OR that too. I am ORing that too. I can give it to D3. Okay. Now D3 is OR. What is D2? D2 is Q2 Q1. Q2 is here. Q1 is here. Q2 Q1. Yeah, this is yes, I will draw it in an abstract. D2 is Q2 Q1, right? Q2 is here. Q2 is here and Q1 is here. Then AND gate here. This here I will get Q2 Q1. Next one is Q2 bar Q1 bar. So I can have Q2 bar is there, Q1 bar is there. Q2 bar, Q1 bar, and these two things needs to be ORed, right? So I should OR these two and give it to D2. Now D2 is ready. What is D1? D1 is Q1 bar. So Q1 bar is going here, so you can connect it to D1. And you can have a common clock. This is clock coming in. Here also that is a clock. Clock is common. Now how we can take out? Q3 is coming out, Q2 is coming out, and the Q1 is also coming out. Okay, so this is the basic logic circuit. This is a basic logic circuit of a counter. Of course, you can have preset and clear. Here I am not showing this preset and clear. Okay, so you can add that preset and clear also. Now coming into a next one. Okay, now coming into a next part, that is drawing the timing diagram. Drawing the timing diagram. Okay, now how to draw the timing diagram? That is the next question. Now see, if you draw the timing diagram of Q3, okay, so better you can go with state diagram, right? Okay, you can, if it is 0, it will go 0, 1, 0, 1, 1, 1, like that you can have. Okay, so that means you can go with timing diagram means you have to go in accordance with the state diagram. That's it. So coming into timing diagram, you can have clock 1, 2, 3, 4, 5, 6, 7, and then going for positive edge triggering. For positive edge triggering. Now coming to positive edge triggering, what do I get? Okay, so I am going for Q3. Q3 is 0, 1, 1, 1, 1. So in the first clock, it is coming in as 0. Then it will be what? 0 is here, then 1, 1, 1, 1. For the 4 clocks, it will be remaining as 1, 1, 1, 1. Then comes 0, 0, 0. To go like this. Okay, that is Q3. Now what is Q2? So this is 1. Now what is Q2? Q2 you can draw like this. Q2 is 0, 1, 1, 0, 0, 1, 1, 0. This 0, 1, 1, 0, 0, 1, 1, 0. So go like that. That is Q2. Now it is Q1. So in the Q1 is 0, 1, 0, 1, 0, 1, 0, 1, like that. This is 0, 1, 0, 1, 0, 1, 0, 1, like that it will go. That is Q1. So I have drawn the timing diagram also. Okay. So that is regarding the design of a 3-bit down counter. Now coming into next one. Okay. This basically 3-bit down counter. Okay. So you can have this 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0, then 0, 1, 1, 0, 1, 0, 0, 0, 1. Like that it will be going. Okay. So next step will be if in the next clock cycle it will be 0, 0, 0. That is the basic That is a basic timing diagram. Okay. Now coming into next question of the structure, that is second question. Design in mode 3 up bar down counter using T flip-flop. Okay. So in the question it is mentioned that you have to use T flip-flop, and also it is an up down counter. So what is basically mode 3? Mode 3 means you need to come from 0, 1, 2, right? 0, 1, 2. You can go for mode 4. That's good. Mode 4 means you get to 0, 1, 2, 3. Then 0, 1, 2, 3, 0, 1, 2, 3. That is in the if it is up counting, and if it is in down counting mode, you can have 0, 3, 2, 1, 0, 3, 2, 1 like that. Okay. So here there are two modes of operation. So for mode for up count and down count, for up counting I am taking mode M as 1, and for down counting I am taking mode M as 0. So that is a fourth input what I need to have. So I need to select the mode. When mode is equal to 1, it will go with up count, and when mode is equal to 0, it will go for down count. So let me go with that. Okay. So present state, next state. So I will draw the state diagram first. So it is 0, 0, 0. So the state diagram. I am going to draw the state diagram 0, 0, 0, 1. Oh, this is only 2 bit, right? You need only 2 bits. So 0, 0, 0, 1, 1, 0, and 1, 1. Because it is mode 4. Mode 4 is 4 means it is equal to 2 square. So you need only 2 bits. So this is basically what? This is basically up count. So this is when M is equal to 1. Now down count means in the exact reverse order. This is the down count. Okay. This is down count. So this is M is equal to 1, M is equal to 1, M is equal to 1. In this case, M is equal to 0, M is equal to 0. We are going for down count. M is equal to 0 and M is equal to 0. So I am having present state as Q3, Q2, Q1. Along with that, I should have a M. Should have a M as input. Now see, if it is if it is going for up count, what happens? Q3, Q2, Q1. So I am going for T flip-flop, so I should have T3, T2, and T1. I am going for T flip-flop. So what should have is T3, T2, and T1. So I am having first I am going for this not 2, 3 is not there. Again that mistake coming in. Q3 is not there and T3 is not there. You can go for only for T2 and T1. That is sufficient. Now it is 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. So first I am taking the mode as 1. Mode as 1 means it is up count. So 0, 0, next state is 0, 1. 0, 1. 0, 1 means next state is 1, 0. 1, 0 means next state is 1, 1. 1, 1 means next state is 0, 0. Okay. Now I am keeping mode as 0. Okay. So if it is 0, 0, next state will be 1, 1. Yeah, 0, 0, 1, 1, 0, and 1, 1. Okay. Now if it is now if it is like 0, 1. If it is 0, 1, what is the next state? If it is 0, 1, next state is if it is 0, 1 means next state is 0, 0. 1, 0 means next state is 1, 0. 1, 0 means next state is 0, 1. 3 means next state is 2. That is 1, 0. Now from here I should write the value of T2 and T1. So what is basically toggle flip-flop? Toggle flip-flop means if present state is complement of next state, or if next state is complement of present state, then only T2 will have value. So 0 to 0, no change. So it is 0, 0 to 1, 1, 1 to 1, 0, 1 to 0, 1, 0 to 1, 1, 0 to 0, 0, 1 to 0, 1, 1 to 1, 0. Now coming into T1, that is 0 to 1, it is 1, 1 to 0, it is 1, 0 to 1, 1, 1 to 0, 1, 0 to 1, 1, 1 to 0, 1, 0 to 1, 1, 1 to 0, it is 1. So we can see that all values of T1 is equal to 1. Therefore we can write T1 is equal to 1. Now you need to find the expression for T2. That is all. Now how will you find the expression for T2? Now see, I need to take M also accounted here. So it becomes 3 bits. So how do you account for M? So if it is 100, it is 4. 101, it is 5. 110, it is 6. 111, it is 7. 000, it is 0. 001, it is 1. This is 2. 011, it is 3. So you need to account for M. M along with Q2, Q1. Then it becomes 3 bits. Okay. Now coming into that. Okay. Coming into T2. T2. Yeah, T2. I am going to for T2. That's it. So here I am having M, Q2, and this is Q1. So 0 and 1, 1, 2, 3. So 0, 0, 0, 1, 1, 1, and 1, 0. Now coming, this is 0, 1, 2, 3, 4, 5, 6, and 7. Now what is the value for this one? For T2, that is 0, 1, 2, 3 is 1, 0, 1, 0. 0, 1, 2, 3 is 1, 0, 1, 0. Now this one, 4, 5, 6, 7 is 0, 1, 0, 1. 4, 5, 6, 7 is 0, 1, 0, 1, right? Yeah. Now how do you derive the expression for this T2? That's it. So how do you find the expression for T2? You can club these two. So what is common? M bar and Q1 bar. So this you will get M bar, Q1 bar. Then we can club these two. So what is the expression for that? That is here 1, 1. That is M and Q1. This M, Q1. Therefore you get T2 is equal to M bar, Q1 bar, or M, Q1. And since all values of T1 is equal to 1, you can make it as 1. Okay. And that is it. Now coming into the circuit, logic circuit. Into the logic circuit. Okay. To draw the logic circuit, you should have 2 flip-flops. That is, T2 is here. T2, Q2, Q2 bar. It's a clock. Then T1, Q1, Q1 bar. Now what is T2? Now you should have an external input, that is M. M bar, Q1 bar. So you should have an AND gate. M bar. So you should have a NOT gate here. M bar, Q1 bar, or MQ1. So M is here. You can have Q1. Q1 we can take like this. One second. Just wait a minute. Q1 we can. I'm going to take here. Yeah. Now both needs to be odd. These two are odd, and that gives T2. Now what is T1? T1 is 1, and clock is common to both. Clock is common to both. Now what are the outputs? Q2 is an output, as well as Q1 is also an output, and we can have preset and clear. So this is the preset pin, preset, and here you can have the clear pin, clear, clear. So now you can have clear. Okay. So this is the basic logic circuit of this up-down counter. That means here when m is equal to 1, it acts as up counter, and when m is equal to 0, it acts as down counter. Okay. So here, if you are drawing the time diagram, you should go with m is equal to 0 case and m is equal to 1 case. So here I am not going to draw with this timing diagram, because there are two cases. One is you should draw for m is equal to 0, and another case is you need to draw for m is equal to 1. And now I am stopping here by forming the logic circuit. Okay, so that is regarding design of mode 4 up-down converter. Mode 4 means it can count 4 states, that is 0, 1, 2, 3. That means only 2 bits are required. Okay, now coming to the third question. Coming to the third question here. Okay, question is design a mode 10. Design a mode 10 up-down counter. Okay, so this is a bit lengthy, but it is easy. Design a mode 10 up-down counter. Okay. Now see, what is mode 10? Mode 10 means you need to count from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Again coming back to 0, 1, 2, 3 like that. Okay. So this is basically in up count mode, and in down count, what should happen? 0, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, again 9, 8, 7, 6, 5, 4, like that it should go. Okay. So that is a up operation and down operation. So here I am making m is equal to 1. There is a mode switch which I can toggle. So here m is equal to 1, and here I am keeping m is equal to 0. If m is equal to 1, the counter acts as up counter, and if m is equal to 0, the counter acts as down counter. Now let me draw the, now second step is you need to find the number of flip-flops required, right? So here mode is equal to 10. So first step is find number of flip-flops. Find number of flip-flops. Okay, so here mode is equal to 10. Therefore you can write cap 10. N should be less than or equal to 2 raised to n. That is 10 should be less than or equal to 2 raised to n. So 2 cube is 8. So we can go for 4. N is equal to 4. That means you should have what? You should have 4 flip-flops. You should have 4 number of flip-flops. Now coming into step 2. Step 2 is you should select which flip-flop you need to work on. So the most easiest one is T flip-flop. So I am going with T flip-flop. T flip-flop and excitation table. I am going with. Okay, because in the question nothing is specified. If nothing is specified, you can go with the T flip-flop. Generally, if the mode is a higher value, you can go with T flip-flop. No problem, because mode is a comparatively high value. Otherwise, if the mode is comparatively less, you can go with the JK flip-flop or SR flip-flop, something like that. But JK is not preferred for going for higher value of modes. Anyway, the design is possible. Okay. Now coming into T flip-flop excitation table. In T flip-flop, if you are taking the excitation table, it will be like this: present state, next state. Okay, that is, here I am having Qn plus 1. What is the value of T? 0 0 0 1 1 0 1 1. Okay, here T is 0, here T is 0. In these two cases, T is equal to 1, because next state is equal to complement of present state. When next state is equal to complement of present state, the value of T is equal to 1, and when present state is equal to next state, the value of T is equal to 0. This step 2. Now coming into step 3, drawing the state diagram. Okay, so it is mode 10, right? So you should have from 0 to 9, 4 bit. So it is 0 1 2 0 0 1 0 3, that is 0 0 1 1 4 0 1 0 0 5, that is 0 1 0 1 6 is 0 1 1 0 7 is 0 1 1 1 8 is 1 0 0 0 9 is 1 0 0 1, that is 9. Okay, this is 0 1 2 3 4 5 6 7 8 and 9. So this is a case when m is equal to 1. Here m is equal to 1, right? M is equal to 1, 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 and here m is equal to 1. When m is equal to 1, it will go for up count. Now if it is down count, what happens? It will go like this. So this is basically a down count. It is down counting, m is becoming 0. It is down counting, m is equal to 0. This m is equal to 0, 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 and here also m is equal to 0. That means here for upcounting, m, the value of mode is taken as 1, and for down counting, value of mode is taken as 0. Okay. Now see here there is a okay. Now if you are coming into these cases, yeah. So we can only count up to 9, right? Yeah. Okay. Now let me draw with the this one present state next state table. Okay. So I'm going to draw with the present state next state table. Okay. The mode. Okay. You can have mode 1 and mode 0. Okay. So here what I try to do is I will try to do with m is equal to 1 first. Then after that I will write with m is equal to 0. Right, okay. So yeah. So present state, next state. So here I am having what? T flip-flop, right? So I am having T4, T3, T2 and T1 because it is having 4 bits, right? This 4 bit, which means that you should go for 4 flip flops. That is T3, T4, T3, T2, T1. So I will go with 1, 1. So it is 0, 0, 0, 0. That is Q3. Sorry, Q3, Q3, Q4, Q3, Q2, Q1. Yeah. So Q4, Q3, Q2, Q1. Yeah. Now in this case, if I am going for up count, M is remaining as 1. So up count means 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. If it is 0, you will get 0, 0, 0, 1, 2, 3, 4. That is 0, 1, 0, 0. That is nested. 0, 1, 0, 0 means it is 5. 0, 1, 0, 1, 5. 6. That is 0, 1, 1, 0. 6 means it is 7. Then 7 means it is 8. 1, 0, 0, 0, 8. Here you will get 9. So this is 9. If it is 9, it should go back to 1, 0, 0, 1. It should go back to 0, 0, 0, 0. 0, 0, 0, 0. In all these cases, M is 1. Okay. Now let me draw and let me find T4 only in base of Q4, Q3, Q2 and Q1. Okay, M is there. So 0 to 0 it is 0, 0 to 0, 0, 0 to 0 it is 0, 0 to 0, 0, 0 to 0, 0, 0 to 0, 0, 0 to 0, 0, 0 to 1, 1, 1 to 1 it is 0, 1 to 0 it is 1. Now coming into T3, 0 to 0 it is 0, 0 to 0 it is 0, 0 to 0 it is 0, 0 to 1, 1, 1 to 1, 0, 1 to 1, 0, 1 to 1, 0, 1 to 0, 1, 0 to 0, 0, 0 to 0 it is 0. Now what is T2? 0 to 0, 0, 0 to 1, 1, 1 to 1 it is 0, 1 to 0 it is 1, 0 to 0 it is 0, 0 to 1, 1, 1 to 1 is 0, then 1 to 0 it is 1, yeah, 0 to 0 it is 0, and 0 to 0 again it is 0. Now coming into T1, that means you should look for present state Q1 and next state Q1. 0 to 1, 1, 1 to 0, 1, 0 to 1, 1, 1 to 0, 1, 0 to 1, 1, 1 to 0 it is 1, 0 to 1, 1, 1 to 0 it is 1, 0 to 1 it is 1, 1 to 0 it is 1. Okay. Now if it is now this is basically I am taking for up count. If it is up counter, we can directly say that T1 is equal to 1. Now what is T4? T4 I will get it as these two elements only, right? Right. So T4 I will get it as what? Q3, Q2, Q1, Q3, U2, U1, yeah, or Q4, Q1, right? Or Q4, Q1. Oh, sorry. You will get Q4 bar, right? Here you will get Q4 bar, here you will get Q4, yeah. Here you will get Q4 bar, and this is Q4, Q3 bar, Q2 bar, Q1. Q3 bar, Q2 bar, Q1. Now see here M is equal to 1. So now you can add M here. Now for T3, what is the expression? T3, here there is 1. So what is it? Q4 bar, Q3 bar, Q2, Q1. Q4 bar, Q3 bar, Q2, Q1. I'm not going for the minimized expression right now. And here also we are having one. So that is here what we have Q4 bar, Q3, Q2, Q1, or Q4 bar, Q3, Q2, Q1. I'm not going for the minimized expression right now. Okay. Now that is T3. Now what is T2? T2 you can form, right? Yeah. T2 I can write it as, okay. What is T2? T2 I can write it as, right? Yeah. What is it? Yeah. T2 means Q4 bar, Q3 bar, Q2 bar, Q1. Q3 bar is Q4 bar. This Q4 bar, Q3 bar, Q2 bar, Q1, or here what they get Q4 bar, Q3 bar, Q2, Q1. Q4 bar, Q3 bar, Q2, Q1, or yeah, I think we will do with the other method. This bit again. So what will I try to do is I will go with the minimization of expressions. Otherwise, you will get more lengthy. Okay. I'm going to get more lengthy. Okay. That is why I am going for it. Okay. Now see, this is for m is equal to 1. Now coming into m is equal to 0, what happens? That we will draw. That we will discuss shortly. Now coming into m is equal to 0 case. Yeah, okay. So coming into the case of m is equal to 0 and m is equal to 1. So m is equal to 1 case is here, so you will get T1 is equal to 1. Now coming into the case of m is equal to 0, I will write present state and state of m is equal to 0 also. Present state and next state. This is a bit lengthy problem, but it is comparatively easy. So Q3, Q2, Q4, Q3, Q2, Q1. This is Q4, Q3, Q2, Q1. So we are having m. For all values m is equal to 0. So what I am having is T4, T3, T2 and T1. So I am having a toggle flip-flop. That is it. So if it is 0, 0, 0, 0, 0, 1, 2, 3, 0, 0, 1, 1, 4, 5, 6, 7, 8, 9. Okay. Now it is 0, 0, 0, it will go to 9. So it is 1, 0, 0, 1. 1 means it will go to 0. Right? So 2 means it will go to 1. 3 means it will go to 2, that is 0, 0, 1, 0. 4 means it will go to 3, that is 0, 0, 1, 1. 5 means it will go to 4, that is 0, 1, 0, 0. Now 6 means it will go to 5, that is 0, 1, 0, 1. 7 means it will go to 6, that is 0, 1, 1, 0. 8 means it will go up to 7, 0, 1, 1, 1. Now 9 means it will go to 9 means it will go to 8, that is 1, 0, 0, 0. Now let me write T4, T3, T2, T1. So 0 to 1, it is 1. 0 to 0, 0. 0 to 0, 0. 0 to 0, 0. 0 to 0, 0. So till here it is 0, 0, 0, 0. Then again 1 to 1, also it is 0. Now coming to T3, what is T3? 0 to 0, 0 to 0 it is 0, 0 to 0, 0, 0 to 0, 0, 0 to 0, 0, 1 to 0, 1, 1 to 0 it is 1, 1 to 1 it is 0, 1 to 1, 0, 1 to 1, 0, 0 to 1, 1, 0 to 0 it is 0. What is C2? 0 to 0 it is 0, 0 to 0, 0, 1 to 0, 1, 1 to 1, 0, 0 to 1, 1, 0 to 0 it is 0, 1 to 0 it is 1, 1 to 1 it is 0, 0 to 1, 1, 0 to 0 it is 0. Now what is T1? 0 to 1, 1, 1 to 0, 1, 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 0 to 1, 1, 1 to 0 it is 1. So in both these cases T1 is equal to 1. So we can write the expression of T1 as 1. Now coming to the expression of T2. Okay, T2 you can take from here as well as here. So for T2 I should draw 2 4x4 and along with that I should go with M. And for T4 also I have to do the same thing. Now how will you go with T4 here? First I will go with T4, then first T1 is there, then I will go with T2. So here I am going to go with T2, right? T2 means 0, yeah, T2. I am going to find the expression of T2. So here I need M is equal to 1, so I need a 4 variable K map here. So it is, I am having 1, 2, 3, 4, 1, 2, 3. So here I am having Q4, Q3, Q2, Q1. 0 0 0 1 1 1 1 0, 0 0 0 1 1 1 1 0. This 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay. Now write it here. So what do you get? If I am writing the decimal equivalence here, so what do I get? 0 1 2 3 4 5 6 7 8 and 9. I am writing the decimal equivalence. So for 0 it is 0, for 0 1, okay, 0 1 it is 1, 2 it is 0, 3 it is 1, for 3 it is 1, for 4 it is 0, 5 1 6 0, 7 1, 8 and 9 it is 0. 8 and 9 it is 0 and all others are don't care. I am taking it for don't care. Okay. So how do you club? You can club. So you can club these 4. Right? It is not an octet, but it is a quad. So if I am clubbing these 4, what do I get? Which is common here? Q4 bar is common and Q1 is common. So it is Q4 bar Q1. And here value of M is equal to 1. So you can write T2 as Q4 bar Q1 M here. Okay. Now similarly you need to take T2 from here also. Similarly you have to take T2 from here. Okay. So here I am going to take T2. So I am going to write the decimal equivalence here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here also I am going to take the decimal equivalence and I am going to find T2. Okay. So just show how to find T2 and after that I will go with the expressions what I am having. Okay. So coming into T2, 1, 2, 3. Now this is Q4, Q3, Q4, Q3. This is Q2, Q1. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now coming into T2, where all we can get 1. At 2 it is 1. At 4 it is 1. At 6 it is 1. At 8 it is 1. Okay. And at 0, 0, 1, 0, 3, 0, 5 and 7 it is 0. 5 and 7 it is 0. Now 9 also it is 0. For all others it is don't care. Don't care. Now how will you take? There is next question. So you can take like this. You can club yeah. Yeah. Okay. Of course we can club these 4. This one option you can club that 4. So what is the expression there? Here Q4 is common. Here what is common? Q1 bar. That is Q4. Q1 bar is there. Then how to add this one? You can have a yeah. Again you can have like this also. Yeah. What is it? That is you will get Q2 Q1 bar. Q2 Q1 bar. Then you can club these 2, right? Yeah. You can club these 2. So I am clubbing that 2. What will you get? Q4 bar Q3, Q4 bar Q3, which is common here Q1 bar. So you can write T2 as Q4 Q1 bar, or Q2 U1 bar, or Q4 bar Q3. This happens when M is equal to 0. So you should write M bar along with it. So this happens when M is along with it. So you will get Q1 into M. Therefore, we can write the entire expression of T2 as M bar and Q4 Q1 bar, or Q2 Q1 bar, or Q4 bar Q3, or Q4 bar Q1 M, or Q4 bar Q1 M. Okay. So that is the expression for T2. Okay. Now coming into so similarly you can derive the expressions for T2, T1. T1 is already 1. And you can have expressions for T2 is there. Now you can derive expressions for T3, T4, etc. Okay, and you can find and you can find the result. So what is T2? T2 what I am getting is Q2 bar. T2 is Q3. Yeah. Okay. Now you are getting the expression of T2. So what you have to do is, so I am not going to derive the expression for T4 and T3 because it is a bit tedious task, but you can do from your end. So what I am going to do is I will just show how it look like. So you should have a T1. T1 is 1. So Q1 and Q1 bar. Now here what we have is T2. T2 is Q2 and Q2 bar. Then here you have T3. For T3 what we have is Q3 and Q3 bar. And next one is T4. T4 is what we have is Q4 and Q4 bar. Okay. So here I am having the clock. So So clock is there. Okay. So T1 is 1. Now I can have the expression of T2. So whatever is in T2, you along with the gate. Okay. So for each, so we can have an OR gate in here. And what is coming in? T2, you will have Q4 bar Q1 M. Q4 bar Q1 M. No need to draw in a circular fashion, so but Q4 bar Q1 M, then M bar Q4 Q1 bar, M bar Q4 Q1 bar. Okay, and you can attach all these things. Then M bar Q2 Q1 bar, M bar Q2 Q1 bar. Then what is coming in? M bar Q4 bar Q3, M bar this one, M bar Q4 bar Q3. So we get T2. Similarly, if you are deriving the expression of T3, just draw the logic here. So it is T3 which are coming in. Okay, I am not going to the derivation of expressions. Okay. For T3 what we get is Q3 Q2 bar Q3 Q2 bar Q1 bar M bar. Here what we get is Q4 Q1 bar M bar. Then here it is Q2 Q1 M. Now for T4 you will get a big OR gate. The expression what we are getting is Q3 bar. I am not going to the derivation of that. Q3 bar Q2 bar Q1 bar M bar. Then here what is Q4 Q1 M, Q4 Q1 M. Then here next is Q3 Q2 Q1 M. So output we can take it as Q1 is one output, Q2 is another output, Q3 is another output, and Q4 we can take it as output. Thus these expressions can be derived. So I have given an example of T2. Similarly you can go with T3 and T4, and I have not derived T3 and T4, but you should do it from your end. So that is all in this lecture. So in this lecture what we have done is we have done with a 3-bit down counter. Then after that we have dealt with a mod 4 up down counter, and I have given a classical example of mod 4 up counter. Then mod 10 up down counter. So it is a bit tough task to design using T flip-flop, but anyway you have to do it. Okay, and I have derived the expressions and I have drawn the logic circuit. Okay, so thank you, and in the next lecture we will be dealing some other examples of this synchronous counters. Okay, and by the end of next lecture you will be getting an idea how to realize a counter. Okay, and after that we will go with asynchronous counters. Thank you.